morning, afternoon, evening, as the case may be. Today's presentation is about how to write insecure code and other stories. But before I start off, I've got a disclaimer. So all the views presented in this session are mine and mine alone. They do not really relate to the company that I work for at all. So by way of introductions, I'm Shruti Kulkarni. I'm a cybersecurity architect with 6.6, now a part of Accenture. I started out my career as a developer, and then I moved on to managing service delivery and service operations. And then I made a career switch to consulting with service management standards and information security standards. That's by way of introduction. So today's
Thank you.
agenda.
Thank you so much, Shruti, for the wonderful introduction. Generally, people hear me first, but today I wanted you to speak first, where they get to know you and especially about the wonderful presentation that you're going to give about insecure code and the developer guide. So I would let you take over the stage and talk more about that. Thank you.
Thank you, Vandana. So with everybody's permission, let me start the presentation. So this is the agenda for our presentation: the simplicity of compromises, how to write insecure code, and the need for a developer guide. So before we start off, I just want to take a step back and give a little bit of a preface to this. So the world is made up of applications, as we know. So except for bare metal servers, and you can all correct me if I'm wrong, but then operating systems, firewalls, browsers, any SaaS application, platform as a service, they are all code that is written by developers. They are all applications. Now, everybody has their best intention when they write it, but if you think about it, any vulnerability in such applications can actually lead to sometimes really huge compromises. So when those compromises take place, the companies get on the front page news, but the ancillary effect is on people like you and me, because it is our data that gets that ends up on dark web or in someone's place, where digital impersonation, identity spoofing, or financial fraud takes place, and eventually we all end up as a statistic in IBM Ponemon report. I don't know how many of you actually refer to IBM Ponemon report. It's a good one to look at the cost of breaches on a year-on-year basis. So with that, I would like to say, having been a developer for a long time, developers are really very creative people. They're very intelligent because they can create something wonderful out of just requirements. And then, but we need to see it from a perspective that developers are not really security people. So that's one aspect of it. And the second aspect is you've got the security assurance team. Let's go with that definition, who actually tell developers how to write secure code. Sometimes the assurance people may not have come from developer background. So you see, there would be some kind of a gap between what the developer sees and what the security assurance team sees. For example, and again, this is just an example, security assurance team may say, hey, do input data validation, so we don't have any cross-site scripting. Fine. Developer says, fine. But what does that actually mean when you say input data validation? Does it just mean whitelisting or allow listing of characters? Or does it mean regex? Or does it mean content security policy? So I think the advice need to be a little spelled out so that the developers can understand and relate to what they are doing so they can implement it in their code. Having said that, we see a lot of such breaches in the wild, and these are all real breaches that have taken place. You can go ahead and have a look at them, and they were all related to application. Like some of them are due to supply chain risk materialization, some of them are due to SQL injection, etc. Now let's see how of it. So this particular video is from Security Shepherd. I don't know how many of you are familiar with it, but it's a wonderful one. So it allows you to see sometimes how simple compromises can be. And there you go. It's as simple as that at times. So now why does it take place? Because there is an asset, there's a boundary. Of course, everything has a trusted and an untrusted boundary. Then you got a threat actor who tries to do reconnaissance and then compromise the application. In this case, SQL injection. The impact of that is loss of confidentiality of data. And then the mitigating factor could be a simple query parameterization. This is what we need to tell the developers to implement as a part of their code. So now, sorry about that. As I explained, developers are really, really clever people. They do the right things. But then sometimes their code can lead to insecurity. So here are some of the compilations, both from what I have gleaned from at the OWASP page, and also what I have experienced in my life as a cybersecurity architect, and also as a developer, the mistakes that I have committed. Now, I would just like to take a pause over here because sometimes cybersecurity architects get caught in between the developers and the assurance team, because the assurance team will not let a particular release to go to production if certain findings are not fixed. At the same time, because we have not given the right kind of guidance to the developers, they may really not know how to fix it, or sometimes it could be a false positive, but they may find it challenging to identify that as a false positive. Also, we all know that developers go through a plethora of training for secure coding, as a part of their activities. Sometimes the huge amount of information that developers get may not really help much. So let's go through the insecure way of writing code. I don't know how many of you can relate to this, but well, we tend to hear that tools resolve security issues. So we really do not need to address security in our code. So this is also known as I do not have to worry about anything. The reason for this is we've got SAST and TAST tools, and additionally, we pen test everything. So pen test is sometimes used as an overarching view and secure all kind of a scenario. The next one is, let me distribute security checks everywhere, so it is secure everywhere. Well, actually, what you're trying to do is security with complexity. And sometimes nobody can find the complexities and identify if there is a security vulnerability in all the secure code that you have written. And then this is what I hear a lot. So some people come back and tell me that, my code is secure, my code is unbreakable. I have never had a proven vulnerability. So what we are trying to apply over here is a default deny principle. It is a security principle, yes, but it is applied in a very different way over here by whoever. I include myself as a developer. So, and then there is also the dynamic code, which loads up at runtime. So reflection and class loading are really beautiful features. But then, do we actually know what the dynamic calls are leading to? So the dynamic calls actually reduce the size of code, but you really don't know what you're running, and then whether the dynamic calls have any kind of vulnerabilities in them, leading to supply chain risk materialization. And this is another one which I've come across several times. Let's not include any input data validation library on my project, because we don't want to add too many libraries in the project. It loads up. Yes, but what if you have a field that requires input data validation? And then I get a response saying data is filtered by WAF. So why include input data validation? Well, a fair point, but WAF is a detective control. It's not really a preventive control. So in spite of WAF, if you choose to accept raw input from the user and actually run a query against the database with it, WAF is not going to secure that, because there are only so many signatures that WAF can look at. And I don't know how many of you actually look up into the number of signatures that SQL injection has, or cross-site scripting has. There are really, really a lot of them. So, this is another reason why you should add something, library probably to your pom.xml file, or use the right kind of framework to do input data validation. And the second one is, the next one is, the language that I'm using is absolutely secure. It's absolutely safe. Well, I don't need to talk more about this. So, people say, we don't need to use secure coding guidelines. Yes, maybe, maybe not. Okay. Then this is something which is quite close to me. People say, we have access control methods that I have designed. It works. But do you know, a lot of compromises take place with access controls. In ill-configured access controls are one of the major reasons why malicious actors get access to unauthorized data or any other aspect that we are trying to secure. And then I write my own logs. We don't want log4j kind of stuff. But the thing to think about over here is, are you actually capturing the right level of events? Because if you don't capture the right level of events, then what's the point in having logs? Because when in production, if something goes wrong, if there is a compromise, how will you ever go back and investigate and detect that kind of a compromise? That's another thing. And I have actually had, if you remember at the beginning of the slide, I referenced an OWASP page. So I have attributed it on this slide. As I said, there are a lot of, I've picked up a lot of information from this particular site, but they all are applied to my own experience as well. And also the mistakes that I made. So you can go and have a look at that link as well. And then there are some more. So we rely on security checks done elsewhere in the code. We write our own encryption standards, which is going to be more secure. Oh, yes. Yes, we have seen that and we have heard about it. Then let's hardcode our keys. Who can possibly want them and what for? Fair enough. Encryption is good. Let's do it everywhere. Client side, server side. And then we've got HTTPS. We really cannot go wrong here. And I think it's not just from, I've heard it from developers, I've heard it from a lot of different people in different roles. Well, no, HTTPS doesn't secure everything. And then I know my own code and I build my own authentication mechanism. Yes, what you are actually trying to do is go to the backend, create a username table and a password table. And one SQL injection, you can get all the usernames and passwords out of your database. So that's another thing to look at. And this is what I call, it's a very interesting one. Because people think, some people think, I'm not generalizing this, mind you, and I'm not trying to be offensive to anybody. It's just some of the stuff that I have seen over a period of my experience. People think that there is no need to apply security controls for sessions because sessions are just random numbers. There's no such thing as session replay or brute force attacks, etc. Oh, believe me, there are. And then hashes. Birthday attacks don't work, so we can use anything. They do work. That's why we got compromises and we got stolen credentials on the dark web. And finally, I love this. Don't worry about it. It's all secure. We have never been breached. Yes, because you don't know if you have been breached. That's the problem. That's why you say you've never been breached. So in spite of all of this, that's why we have got compromises taking place. Lots of them. You see a lot of news making on application compromises. I just want to say over here, I do come across scenarios where people think securing the infrastructure is very important. Yes, securing the infrastructure is really, really important, but you may have a perfectly secured infrastructure, but once cross-site scripting on the application can really bring down the whole thing. So something to think about. And the impact of all of this is, tools really do not capture defects. And they capture defects at a later stage. in the development. They do not fix any defects. I know there are some people who say the tools fix defects. No, they don't. You really need hands-on activities to fix your defects. For example, a missing signature for encryption of data on a mobile app. When you actually encrypt your data, wherever it is, be it on a mobile app or for a web app, you use a symmetric key to encrypt your data, but then the symmetric key itself is secured with a key encrypting key. So if you have come across any such scenario where a tool can detect a missing key encrypting key, please let me know, but I've not come across any of that. And then there is the next one about privilege escalation. So if you do example.com and append it with /admin.asp or JSP or PHP or whatever the page may be, the tool can't detect that. This needs to be tested hands-on and needs to be fixed. So these are some of the examples where tools may miss detecting vulnerabilities, what we have mentioned here. And also, going back and fixing defects is rework, and it takes a lot of time. It's just rework. So, exploitive vulnerabilities like SQL injection, excesses, supply chain risk materialization, they all lead to reputational loss for the organization, and in turn, probably financial loss as well. So if there's going to be financial loss for the company that you work for, it may also impact your paycheck and bonus. Something to think about again. So make your life simple, save time on rework, and if you as a developer do not put security in the code, no one else will. Please note that. And then writing security code is really, really not equal to testing the security of code with tools. So, and more importantly, if you find a workaround, let your security lead know about it, because workarounds are typically exploits. So if you have found it, probably someone else will find it too. So how do you make your life simple? You can use secure SDLC, and then use secure coding guidelines, managing licenses, securing your environment, using trust boundaries, etc. I just want to, I know there are a lot of things on this, and I contradict it when I say that, make your life simple. But I'll come to how you can make your life simple with this. But I just want to highlight one point about licenses. I really don't know how many of you actually have come across this scenario, but sometimes if you don't pay proper attention to the open source software and the license that you're using, and if it's not MIT or Apache 2, you will realize during your release phase that you may have a commercial implication on using certain products. So it's something, if you identify it early on in the life cycle, you may choose an alternative product, or you may actually have a different way of using that product. But the key thing is identifying it early in the life cycle, so you don't come across this during the later phase and during your ship to production timelines. So as I said, I'm contradicting when I say make your life simple with so many of these, but you can indeed do all of this stuff with our developer guide. So what our developer guide talks about is architecture and design, threat modeling, secure design, risk assessment, and along with it, we have got a lot of guidelines for input data validation, Auth-in-C, cryptography, error handling, images and containers, open source secure, open source software, logging and auditing, infrastructure as code, session management, and so on. We've got lots of guidelines, and we've got checklists to boost with it. So what is it that we're doing with the developer guide is we are trying to provide the overarching view of how secure software can be developed, architected, and written. So that's why we are not just focusing on secure coding guidelines. We are looking at environment, architecture, testing, threat modeling, secure design, open source software licenses, do's and don'ts, etc. And we also have got links for various aspects of security, like security architecture and threat modeling on the developer guide. So, and we have got given a link over here. It's to to the developer guide on OWASP page. So this is what it looks like on OWASP portal. But what it is not trying to redefine existing components. So we are not trying to reinvent the wheel. We are reusing whatever is already available. And it's not really a technology specific secure coding checklist. So for example, we don't have something for Angular and for React or for C# or for PHP and all that. The reason is over a period of time, the way people do it changes. For example, 20 years ago, it was mostly allow listing characters for input data validation. Then came regex, then came secure libraries, then came secure frameworks. So if we are being very specific about technology, sometimes it might become quite challenging to update it and keep it up to date. But having said that, if you would like to create any technology specific secure coding checklist, please feel free to do so and then stick it in our repository. So these are the links on GitHub for our developer guide, and this is what the developer guide looks like. I've gotten a print in PDF format, but unfortunately I'm unable to open it on a full screen share mode. Okay? So what are we really asking for over here? So we need volunteers to review the available content, add missing content, and enhance the existing content. This is because none of us live long enough to make all the mistakes in the world and learn from them, and nobody knows everything about everything. So we actually need to have a place where we can add our learnings and support our community, all together, because together we can make our applications stronger, so that the community can benefit from it. So here is a team. We are 5 of us as project leaders. So you can contact any of us. Our contact details are on the OWASP portal. It's Andra, Harold, John, myself, and Vandana. And one of us will definitely respond to whatever questions you may have about Developer Guide. And these are our sponsors. So we would like to thank Defect Dojo, our sponsors. And if you would like to be a sponsor of Developer Guide, please let us know and also contact us to know more about sponsorship. Also, there is a link towards the end about the sponsorship details and guide. So that's all I have. Thank you very much for listening to me.
Thank you so much, Shruti. It was wonderful. And we are totally smitten by the work that is gone into the developer guide, which was long back updated, but now everyone is putting in so much effort in that. So it's totally amazing.
Thank you. Thanks very
Yeah.
much.
And looking forward to see what things unfold. And to all the organizations, please consider sponsoring the project, because this is something which is very important for the developers and for all the students and anyone who wants to volunteer to open source. This is one good project, so you should definitely check this out and contribute towards this project. Thank you, and thank you so much, Shruti.
Thank you. It was a pleasure being here.
Yeah, thank you so much, and looking forward to meeting you in person again soon.
Oh, absolutely. Me too.
Yeah, thank you so much. And thank you so much, everyone. We will meet soon again, and take care. Bye bye.
Take care. Bye then. Have a nice day. Bye.